In this lecture, we're going to solve problem number 3 in the area attack problem set from the Julia Robinson Math Festival problems. And here we have 6 unit circles surrounding a circle in the center. And the question is to compute the area of this 6-petaled flower-like thing in the middle. And there may be a really clever way to do this, but the approach I'm going to take is to compute the area of half of one of these petals. And you can see that if I'm going to take, say, this circle here, and my goal is to split this line down the middle and compute the area of the outside this circle. So that's what we're going to do. And you should note that since this is half of a petal and there's 6 of them, we're going to have 12 altogether. So how does this work? Well, maybe I can draw a better circle this time. But we have this circle, and it's divided into 6. Okay, and this is 60 degrees, it's 6, and we have this half petal. So basically, we want to find this area. And it's a unit circle, so this is length 1. So because the whole thing is a unit circle, we know the area is pi r squared. So the area of this wedge is 1/6 of pi squared. So that's the big part. Now we need to know what's the area of this equilateral triangle. So let me draw this over here. Or rather, let's do it with, we have one here already. Okay, and we know that this is equilateral triangles. This is 1, this is 1, and this is 1. And so we need to know what's the perpendicular bisector angle. So this is a half, and this is a right angle here. So for the Pythagorean theorem, we know that 1 squared equals 1/2 squared plus, let's call this y, plus y squared. So that gives us 1 equals 1/4 plus y squared, or let's go over here maybe, y squared equals 3/4, or y is equal to the square root of 3 over 2. So the area of a right triangle is 1/2 the base times the height, so let's call this area A. A is equal to 1/2 the base, which is 1/2, times the height. And we have 2 of them, so we can basically get rid of this. And so the area of the whole thing equals square root of 3 over 4. Okay, so we know what the big wedge is. The big wedge is pi over 6. It's a little bit bigger than a half. And the area of the triangle is the square root of 3, which is sort of like 1.2 over 1.7 over 4, so that's a little less than half. And then, as I said, this is 1/2 of one of those petals, and we have 12 of them. So the whole thing is going to be times 12. So 12 times pi over 6 is 2 pi, and 12 times square root of 3 is 3 square root of 3. So if I did that right, that's the area of all 6 petals. And that's the answer.